Okay, so we're going to be going over a DFA problem, and essentially we're going to be giving a transition table here and then all of our 5 characteristics that make up a DFA. So first, the Q stands for the states. So right here we have the states that exist in the DFA. The next symbol over right here is going to be the alphabet, which is going to be, for example, it could be 0, 1, or a letter like A, B. Then our next symbol here is going to be the transition function, which in this case, we have a transition table right here. And I will be showing you how to use the transition table in order to convert a DFA, this transition table, into a DFA. Then our last two are the start state and the final state. In start state, we'll always have an arrow pointing towards it, and then the final state will have 2 circles around it to make sure it's an accept. It's also known as an accept state. So here, we're given these things, these values here, and then we're also given our start state and our final state, which we don't know yet. But let's say in this case, it's gonna be Q3. So this is Q3 right here. And then we are going to start building our DFA. So essentially, we want to start off, we look at Q1. We have these 5 states that transition to all these states. We're going to have 5 states. We have Q1. I'll make this nice and big. So Q1, that is our start state. And we're going to make this is just a normal table, but we're going to say this is our Q1 will be the start state. Yeah. Now, Q1 is going to have from U, so it's going to go Q1 to Q1 right here. Q1, you have U goes to Q1. So you're going to have a thing like that, and it's just going to be U. Then our next is Q1 to Q2. We're going to create Q2, Q2, and it's going to be a D. Essentially what this table is doing is it's just telling us which one goes to which. And that's how you need to understand a transition function. Which input is going to allow me to go to the next state in the output. So we're done with Q1 to Q2. Now we move to the second row here. We have Q2 and it goes back to Q1, but that's a U. So you're going to take this is going to go to U. That's U. Then you have Q2 to Q3, which is you make a Q3 here, and you're going to basically connect the Q2 to the Q3, and it's going to be a D. So you go here, and it's D. Yeah. Make sure you guys still see that. And then basically it's self-explanatory. You do the same thing with Q3 to Q2. But we know our Q3 is going to be, we're going to say it's our final state. So we're going to make a double circle around it. And then we go Q3 to Q2, which is U. Q3, you'll hear U. And then Q3 to Q4. Q4. And it's going to be AD. And essentially, I will finish the remaining steps, but you just want to keep following that Q4 to Q3. Q3 is a U, so we write another U. And then Q4 to Q5 is D. And we have to make it Q5, write a D. Then Q5 here is going to go to Q4, which is a U. And Q5 to Q5 is a self loop. So we're going to do a self loop, and it's going to be D. And basically, that's how you solve a DFA given a transition table. And make sure you guys just know all of these symbols as well. Where we have the states. This is all the states. You're going to be given some type of DFA. You're going to be given some alphabet symbol, which could be like 0, 1. In this case, it's U and D. So that responds to your alphabet symbol. Sorry about that. And then we're going to get a transition function, which is the third symbol here, with a start state and a final state. and you follow this table and you form a DFA, and this is the correct DFA.